Hello folks, this is video number 10 for the 3D Experience CATIA Generative Shape Design application. The playlist that this video belongs to is called the Surface tab because I already have another playlist for the wireframe tab in the 3D Experience CATIA Generative Shape Design. The icon that we're going to discuss is multi-section surface, and I'm spending quite a bit of time on this because it's one of the more complicated icons with lots of options and scenarios within the GSD of CATIA, 3D Experience CATIA. The particular example that I'm going to do involves a simple case of two open profiles. And in it, I will talk about the options that you've got for coupling, namely the ratio, tangency, then curvature, and vertices. So if you look at the ribbon in the generative shape design, you see that it looks like that, bottom of the screen. And there is a surface tab here, and within the surface tab, there is the multi-section surface. When you click on it, you get a dialog box like that, and there's a lot of stuff hidden in this advanced options, and this is what we're going to be talking about. Just to let you know that multi-section solid also appears in part design, and there's quite a bit of similarity between the two, but there are some subtle differences too, okay? So when you expand this advanced option, you get an extensive menu down here with lots of things that you can do. For example, if you look at the coupling sections, coupling type, there is 4 different options: ratio, tangency, then curvature, exactly like this type, and vertices. Now, when you do multi-section surfaces in 3D Experience, the default is ratio. Okay, the default is ratio. But when you do solids, the default is tangency, then curvature, I believe. Now, the example that I'm going to do is two profiles like that, two open profiles like that, which are separated by a plane 15 millimeter. And the only reason I'm giving dimensions here is that in case you want to follow this and do it together, at least you know what these numbers are. Now, here's one profile. This is the other one. So if you put a grid, you look at the view from the front. The view from the front looks like that. So these are the dimensions for that back profile, and these are the dimensions for the front profile. And notice that at these 4 points, there is a tangent discontinuity. Okay, when you say tangency, what is really referred to, meant in 3D Experience CATIA or CATIA V5, is the discontinuity in tangency. So these are the 4. And there are 2 which are discontinuity in curvature. Because notice that the curvature, if you look at the back profile, which means this top one, the curvature of this circle, this curve is 10, and they have they're tangent to the bottom one, but they have different curvature. The bottom one has a radius of curvature of 5. And same thing down here at these other locations. Now, just so that we do this thing easily, I'm assuming that these are the global origin, 0, 0, 0. We view from the front, okay? And this is how it's going to look like. We're going to do that. Now the help, the help is not helping that much because that source of confusion with the name actually spelled out here, which is good, okay? It says, when you talk about tangency, the curves are coupled according to the tangency discontinuity points. And here with tangency, when you talk about tangency then curvature. Uh, the uh, the points of interest are curvature discontinuity points. Kind of uh, misleading, in fact, the naming, the names that they've chosen. Now, this is a good reference. This is a good reference. The only problem is that it was done maybe 4 or 5 years ago, and the interface and things like that have changed. I'm using release 2026X of 3D Experience CATIA. Now, one other thing, when you're doing multi-section surfaces or even solids, because of the many options that you have, there may be conflicting information between what you input. So either it will not work, you get an error message, or it may work and it's not what you expect. Just be aware of the fact that that's one of the issues in this particular icon. All right, so let's go ahead and do this. I'm going to create, first of all, a plane, 50 millimeter offset from this vertical YZ plane. So let's go to wireframe. Here is a plane. Here is 50 millimeters. There we are. This is the front plane. This is the back plane. I don't need X1, Y. I'm going to hide this. And I'm going to hide the XZ plane. Okay. So let's go ahead to the YZ plane and drew that back profile. So let me remind you what the back profile is. It's this top one. Okay. So on that, I'm going to sketch. Let me draw that middle circle first. Middle circle, half a circle. So center that 0, 0, 0, half a circle like that. Okay. And the radius of it is 10. I'm drawing this thing, 10. Radius 10. 10 millimeters. Okay, good. Now what else do we have here? Then we have a half a circle going down below, radius 5. So let's do this. Here is a half a circle. We'll fix the radius in a minute. Okay, so this is going to be 5. Good. And notice that these are tangent, but there is the discontinuity in curvature. And then I draw this 10 millimeter to the left, a line 10 millimeter to the left from here, 10 millimeter to the left. Let's dimension this thing. Okay, I better put this thing back where it was. This was 10. And this was 5, right? Okay, very good. Now, what do we have here? We have quarter of a circle. So let's do this bottom one, quarter of a circle. Starting there, quarter of a circle. We're going to clean it up in a minute. Radius of that is also 5. Okay, now the only thing is that let me draw a vertical line here, construction line, because I want to make this angle to be, or this point to be coincident with that, okay? So this point, control that line to be coincident. I can dimension it and say coincident or some other way. All right, and finally, there is a 45-degree angle. You can see that there's a 40, oh, this should be 10 actually, sorry. I'll make this thing 10, and then there's a 45-degree angle, length of 10. Okay, so let's go back here. This should be actually 10. Good. And then I'm going to draw a line from here to that location, which makes this thing 10. Okay, so that's good. That is my back sketch. Let me exit. So what you see there is this back sketch. Okay, now I do the front one, which looks like that. So on that plane, I will sketch. I want a circle of radius 5, half a circle of radius 5. Let me dimension this thing. This radius is 5. What else do we have? We go down, radius of 10. So another half a circle. Let me dimension this thing. 10. Okay. And then we go a line 10 millimeter to the left. So a line going from here to there, and I'm going to dimension this thing to be 10. Good. Now let's do the other side. The other side, there's a quarter of a circle, radius 5. Okay, so let's do this. Zoom in. Okay. All right, let me make this in radius 5. Okay, by the same token, I'm going to draw a construction line here, and we're going to, there's a construction line, and I'm going to take this, control that, make it coincident. Very good. And finally, a 45-degree angle there, right? So let me see, 45-degree angle. Yep. A line going from here to, well, I'll go to somewhere there, and then I make these two parallel. How about that? Let's control that. I guess we can make this angle 45 degrees. How about that? It's better. It's easier. So this angle with that construction, 45. Excellent. So exit. There we are. So what you see there are actually this drawing. Now let me hide some stuff here. So for example, I don't need this plane. I'm going to hide it. I don't need this plane. I'm going to hide it. And this is the axis for sketch 1. You can hide. Gone. And this is the axis for sketch 2, which also can hide. All right. So here's the situation. Let me remind you that this point and that point, their curvature discontinuity. The curvature changes. The tangency, there's no tangency discontinuity, but there's curvature. Okay. So now we go to surface, and here's a multi-section surface. Let's move on the side. This is going to be my first profile, first section. And this is going to be my second section. Notice that they both point in the proper direction. We don't have to worry about closing point because we're dealing with open section. Now, let me close the advanced option. We already did this. Now we go to the advanced option. Notice that the default is ratio. If I say preview, what it does is that it starts at this location and goes along the arc, along the curve, find it, for example, 10%, 15%, 20%, and does the same thing on this side. And for corresponding percentages, they connect them with a straight line, and that's how the surface is generated. So if I do ratio, then I'm going to say preview. It looks like that. Let me close this thing. So this is why you have these extra lines, because it goes along this back curve and percentage by percentage find the corresponding location on this curve, front curve, and connect them, and you get this surface. For example, 5% of the curve in the back may be here, 5% of the curve in the front may be a different location, some other location, connects them together, and that's how the surface is being generated. Now, let me hide a few things here. Let me hide, well, actually, we'll leave it like that. We're going to hide it later. We can hide these sketches. Let me hide this sketch, and let me hide the front sketch. Good, good. Now, if you double click on this, you can go from ratio to tangency. In other words, get the points that the tangent is not continuous, any sharp corners on both curves, and connect them together. So you select this, and then you say preview. Remember, there are these extra lines here, preview. Notice that these extra lines disappear. Yeah? So what it did, it connected this point to this point because there's a tangent discontinuity. It connected this point to that point, there's a tangent discontinuity. Okay, now, if you change this thing to tangency, then curvature, that means first connect the points that the tangent are discontinuous, and then go and figure out where are the curvatures discontinuous and connect them. So if I select this and say apply, notice that right now there is no line, visible line. Okay, so notice that it did connect this point to that point, and same thing, this point to that point. The locations where the things were discontinuous, the curvature was discontinuous. As a matter of fact, let me cancel, let me say okay, and let me bring in the sketches. There we are, on the front sketch. Okay, so these are the locations where the curvature discontinuity. And there is a line which connects this to the other one. Now, if you double click on this, and let's go back to the tangency instead of tangency, then curvature, and then we say preview. Okay, notice that those points are not connected directly to each other. They are connected somehow. For example, this point may be connected to some other location over there, but it is not quite what we expect. Okay. Remember, tangency means just connect the points that the tangents are discontinuous. But when we do tangency, then curvature, it connects also the points where the curvature are discontinuous, namely these places where the arcs come together. And finally, in this particular problem, even if you go to vertex, it'll work. Let's see if it makes a difference. It didn't make any difference. Okay. So you got to be careful with these. The default is ratio, and then these will give you other type of surfaces, could possibly give you other kinds of surfaces. However, you don't get always what you think you're going to be getting. Yep. So my next video is going to be two closed profiles, and we're going to go through this business. There we are. All right, folks, good luck.